All right, from the top. Hello, everybody. Welcome to SRA 365. I'm, of course, Professor S, and this is today's lecture. So here's what we're going to be doing today. So before we go over the practice problem solutions and the lecture for today, we're going to talk about how we're going to wrap up phase one. See, the thing is, it's like there's 3 different phases, and we have an exam next week, and so thought you should know like the basic schedule. So let's just talk about that. So first of all, today what we're doing is we're learning about testing proportions. Monday is review. We'll go over the practice problems that were due. We'll talk about how to prepare for the exam, and then we'll address any other loose end questions that you have about phase one. On Wednesday, we'll have the exam, and I'll tell you more about like what to expect on that on Monday. That's what the whole prep for exam is. And then on Friday, when we come back, we will begin phase two. And of course, I didn't include that here because this is the schedule for phase one, and that ends on next Wednesday. So, wow, how the semester flies, right? All right, anyways, here are the practice problem solutions, and I believe I'm in the way. Hold on one second. All right. And there we go. I figured there's enough room down here for me. Anyways, that's the practice problem solutions. All right, so today what we're doing is we're talking about testing proportions. So far we've tested means, but now we're going to do in proportions, which is not that much different, but it allows us to do much more things that we can test. So when we're talking about proportions, we're talking about the population proportion. So think about the amount, like for example, the proportion of people who are likely to vote for a candidate, the proportion of infected computers that are part of a botnet, the proportion of people who love PSLs, right? I mean, like we can find all these different things, but the idea is like we don't know the population mean, we don't know the population proportion, so that's why we test it, right? And so, like I was saying before, the test statistic is really the one thing that's different, and it's not too much different than the Z that we did for when we were testing the population mean. Right? So we're only going to be using normal distribution for this one because notice we don't need to know what the population standard deviation is, right? We're just comparing the proportion that we observed in our sample versus our hypothesis proportion, okay? So the p hat, that's the observed proportion. The p naught, that's the p0. That's the whatever it's called, the hypothesis, the null hypothesis proportion, okay? And we just plug it in and we get our Z. So here, let me give you an example. All right, so a restaurant owner is paranoid that customers are going to blast his restaurant on Yelp. He is convinced it is more than 25% of his customers will not only find something to complain about, but they will do it on Yelp. He surveys everyone that comes to his restaurant for 3 days. He finds that 123 people of the 216 guests he surveyed said that they were going to post a review on Yelp right away. So the proportion that he observed is about 57% because 123 divided by 216 is about 0.57. Okay? So think about like what are our hypotheses, right? So he's thinking that it is more than 25%. So then the null would be that it is 25%. The alternative would be that the proportion is more than that. So then we plug in the values in Z and we get 0.570 minus 0.25. You can read, right? And then when we solve that out, we get about 10.842. And so if you think about that Z, just think about it for a second. So far, when we've done Z's, like if you think about the bounds, like when it's the first things of standard deviation is about 68%, next is about 95, and the next is like 99.7, right? So 3 standard deviations makes up for 99.7%. And so then if you think about what's on the outside of that, it's really tiny, right? And so if you even look on just like one side, that's really tiny. And so imagine not 3 standard deviations, but over 10, right? Tiny, tiny, tiny. P-value is going to be super small, right? And in fact, it is. Here's the p-value right here. So based on his calculation, is he justified? And the answer is yeah. There's probably flaws in his method for attaining his data, but his calculations based upon this calculations, yeah, they're going to go on Yelp. I don't know. Maybe they'll say something nice. Maybe being in their face is not that helpful, but I don't know. This is just a hypothetical situation that didn't really happen. But the idea is like, this is very similar to the hypothesis testing we've done before. It's really just the difference is finding a different Z. Okay. Anyways, I think that's good enough for today. Good luck. We'll see you all Monday. Bye. Hey everyone. Hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.